Last thing is adding and subtracting variables. Make yourself a little side note for this last problem. You cannot have a radical in the denominator. That's bad math. Alright, moving on. Example 11. We've got 5 times the square root of y plus 6 times the square root of y. We've practically done this already. These are like terms. They're both the square root of y. That means we can add them together. 5 plus 6 is 11 square roots of y. Example 12, we have 12 times the cube root of 2z to the 5th power minus z times the cube root of 54z to the 2nd power. Alright, like I said, the cube root of z to the 5th power and the cube root of 54z, those are not the same. They are not like terms. So like we did at the beginning of the lesson, we can try to simplify one of them. Obviously, we can, let's start here. We've got 12. Cube root of 2, we cannot take the cube root of 2, so that 2 is going to stay underneath the radical. For the z, 3 goes into 5 one time, so 1z is coming out. 3 goes into 5 one time with 2 left over, so z squared will stay underneath the radical. Minus, alright, let's try to take the cube root of 54. There is no cube root of 54, so we're going to have to break 54 down. 54 splits into 2 and 27. Now remember, we're taking the cube root. If either one of your initial factors are a perfect cube, you can go ahead and take the cube root of it. The cube root of 27 is 3, so that's going to come out. And what's going to stay underneath the radical is the other factor, which is 2. Now as far as the z, the cube root of z squared, 3 does not go into 2. We cannot take the cube root, so the z squared will stay underneath the radical. The only thing we need to remember to bring down is this z that was there to start with. Now I have like terms, cube root of 2z squared and cube root of 2z squared. I can subtract these. 12z minus 3z gives me 9z cube root of 2z squared. Alright, last one. Square root of 9w to the 5th minus w times the square root of w cubed. Okay, first thing we need to do is try to take, we're working with the square root now, square root of the number. The square root of 9 is 3, so a 3 will come out. Remember, the secret index of the square root is 2. So 2 goes into 5 2 times. So w squared comes out. There's your 2 times. However, it goes into 5 2 times with 1 left over. So 1w will be left underneath the radical. Minus. This w is still there, so we're going to leave it. Same thing here. The index for a square root is 2. 2 goes into 3 one time, so I've got another w that I'm pulling out, and the only thing that's left, 2 goes into 3 one time, so and 1 left over, so 1w will remain underneath the radical. This gives me 3w squared square root of w minus w times w is w squared square roots of w. Now again, these are like terms. I've got the square root of w, the square root of w. This is w squared, and this is w squared. So I can, or not multiply, I can subtract these. 3w squared minus w squared gives me 2w squared. And then we also have that square root of w there.